So our second speaker of the day is Adrian Mouat, who has been involved with containers from the early days of Docker and also authored the O'Reilly book using Docker. Now, recent developments in the cloud native space convinced him that Rust and WebAssembly will become a very important part of our cloud native future, and he's here to talk about why it will, as in WebAssembly, will take over the world. Please welcome Adrian.
Thank you, Zoltan. Yeah, so I'm going to talk about WebAssembly and why I think it's going to be a major part of our industry going forward. And why, in fact, that most of you are listening, I suspect you may well use WebAssembly in your future, either directly or indirectly. So I guess I should start by saying a little bit about what WebAssembly is. But I'm actually going to open with the standard joke. I first heard Ashley Williams tell it, but I think it's a standard joke in the industry. And it's that WebAssembly is neither web nor assembly. So maybe arguably not the world's best name. The reason it's not web, it is web. It's just not just about the web anymore. It also runs like server side in IoT and things like that. The reason it's not assembly is a bit more pedantic though. And basically an assembly language targets concrete CPU hardware, so actual hardware like x86 or something, which is, you see an example here of in the slide. But WebAssembly targets a virtual architecture. So technically it's not assembly language. However, that also makes me wonder if we create a chip that runs for WebAssembly, does it then suddenly become an assembly language? But that's me thinking idly. The other thing that it's not is it's not a replacement for JavaScript. And in fact, you might even see more JavaScript because we can use JavaScript to create WebAssembly, and you typically need a lot of JavaScript glue to use WebAssembly, especially in the web and browsers. Okay, so that's what it's not. What is it? So it's not an assembly language, it's actually a bytecode. So you can think something like Java bytecode, or if you're in a Microsoft world, I believe there's the .NET Common Interpreted Language, CIL. It is a lot simpler than those bytecodes, however. So in some ways, it's actually closer to an assembly language. And because it's a bytecode, it will run anywhere that it has a host runtime that understands that bytecode, regardless of architecture or anything. Another way of thinking about it is very close to the way we think about containers, to be honest. And one of the reasons that I'm so interested in WebAssembly. You can think of WebAssembly as just being a safe, portable way of building, packaging, and running code. I think I took this quote from somewhere, but now I can't find the original source. So unfortunately, I can't attribute it. If anybody knows, you can let me know. Okay, so you won't write raw WebAssembly yourself, or most likely. Instead, you'll use an existing language like Go or Rust or assembly script to compile down into WebAssembly bytecode. If you've not heard of assembly script, it's basically a dialect of TypeScript, the JavaScript language that compiles nicely to WebAssembly. And once you have your WebAssembly, you need somewhere to run it. It's not like an exe that runs natively on or a binary that runs natively on your hardware. You do need like a host runtime to run it, just the same as with Java, etc. And the number one place, or the original place where it runs is in the browser. So things like Chrome, Firefox, Opera, all the rest of them. But there are other options for runtimes. So I've got a picture here of WASM. I chose WASM purely because that project has a logo, but there is a lot of other options like WASM Time and WASM 3 to run WASM on the server. Another place you're going to see it used a lot is embedded in other platforms. So I've got the Ethereum logo here because Ethereum are moving to use WebAssembly as the format for their smart contracts, which I think is a really interesting use case, regardless of what you think about cryptocurrency. Another really place you'll see it used is in functions as a service platform. So they have WebAssembly runtimes that will run WebAssembly. And the most notable implementations are Fastly's Computer Edge and Cloudflare Workers, both of which will run WebAssembly natively for you. Okay, well, what is WebAssembly underneath the hood, if you like? And basically, the WebAssembly virtual machine, or whatever you want to call it, is very simple. It's a stack-based architecture, as opposed to like a register-based architecture. I'll explain, to explain what that means, it's actually easier if we look at a source code, which we will do in a second. It's only got 4 types, 32-bit integers, 64-bit integers, 32-bit floats, and 64-bit floats. It's got a concept of linear memory, which is basically the heap, or just like an array of straight bytes. And you can share that memory between the hosts, so like JavaScript or whatever, and the WebAssembly itself. So it's a way to pass data and functions between the two places. But it is just raw bytes, so you have to take care of like marshalling structs in and out and allocating memory, etc. It doesn't have anything like garbage collection at the minute. I believe they are working on some sort of garbage collection implementation though. And it doesn't, it's very limited in the operations it gives you. There's nowhere near the sort of level of operations stuff that you actually get in Java bytecode, etc. It's much closer to assembly. So the easiest way to really understand what I'm saying here is to look at the source code. Normally, you wouldn't write WebAssembly by hand, but it is totally possible, and it is quite informative to do so. So I'm going to move to a demo. As we all know, this should be a simple demo, but sometimes simple things go horribly wrong, as we saw last year with the Ever Given. So I'm going to try stopping sharing it and sharing my terminal. Apologies if I've given the people a heart attack here. Hopefully this will work. So hopefully you can see my terminal now, and I hope it's a reasonable size for you. So I'm in this WASM basic folder. Let's remove this add.wasm file. And we've got this add.wat file. So WAT is WebAssembly text format. And basically it compiles down to WASM, and it has almost a one-to-one correspondence. Sorry, let me take some. Oh, it's a little dry. So here we're declaring a WebAssembly module with a single function. I would have liked to have like a hello world function here, but hello world, it's very informative in WebAssembly, and it's a good way to understand how it all works, but it's really not that simple because you have to take care of like encoding the bytes, handing them to the linear memory, and decoding them again. So it's actually a lot more work than you'd expect. So in this case, I've opted for a simple function that just adds 2 numbers and seems to be very common in WebAssembly tutorials and so on. So we have this function $add. It takes 2 parameters. They're both of type 32-bit integer, $a and $b, and it's going to return a result that's also a 32-bit integer. Now, this is the point I was trying to get to about being a stack-based architecture. So the final operations here is this add operation, but we don't give it any operands. Instead, it's going to go to the stack to get its operands. So what we do is we run this local.get function, which is going to get the parameter $a and put it on top of the stack. Then we're going to run local.get and get parameter b and put it on top of the stack. And then we're going to run the add function, which will go to the stack, pop the 2 top values off, add them together, and put back on top of the stack the result of adding them together. Finally, we've got this export line. So we want to make this function accessible to the host runtime. So like JavaScript or wherever we're running this. So what we're saying is export this function and give it the name add. I should also point out there is a slightly cleaner way to write this. I intentionally didn't use this format to explain sort of stack architecture, but you can also write things like this, which is a little bit easier to understand, I guess. It's basically like a list-based expression format. Okay, so we have this add.wat file, and we want to compile it into actual WebAssembly. So we have a wat to wasm function that I can use, or a compiler that I can use. There's also wasm to wat, so you can decompile WebAssembly bytecode back into WebAssembly text format, which is quite cool. But what we're going to do is call wat to wasm and add.wat, and we want it to create add.wasm. Okay, and that's done that. And you can see, yeah, that's just been compiled this minute. I'm in the UK, so it's 12 minutes past 3 at the minute. Okay, so we have our WASM file. The next thing I want to do is run it, and I'm going to first run it in the terminal. Well, actually, I'm going to look at my history so I don't get this wrong. So I'm going to use WASM to run it. I could also use WASM time. And what we're going to do is tell WASM to run add.wasm and invoke, so -i is for invoke, the add method, and give it arguments 2 and 3. And it returns 5, thankfully. Yeah, so if you give it like too few arguments, it will give you an error and so on. Okay, so the next thing you're probably interested in is seeing it run in the browser. So I've got a very simple HTML file here. This was as simple as I could make it. It's just an HTML file with a single script function inside it. It has, and this function is called WebAssembly.instantiate streaming and loads this add.wasm WebAssembly file, which will return a WebAssembly instance. On that instance, there's several fields. Apology if fields isn't the right name. I'm not a JavaScript programmer. So there's several fields, including imports and stuff, but one we're interested in is exports. So exports includes all the functions that were exported from this WebAssembly, which in this case is our add function. So we're calling exports.add and giving it arguments 2 and 2, and then we're writing the result to the document body. Okay, so I'm going to use a very simple web server called Miniserve, which is a Rust-based thing. You could also use, I think a lot of people use Python as a simple web server. And you could pretty much use what you like. I think the only gotcha is it does have to understand the WebAssembly content type. Okay, so now I'm going to move back to my browser. And open localhost 8080. And yeah, we've got our, this might be very small for you, but apologies if that's the case. But we do have the result, which is 2 + 2 = 4, which is possibly the most uninspiring demo ever, but it does prove that it worked. Now, there are some cooler demos. So I found this guy called Ben Smith that seems to be really involved with WebAssembly. And he's got some really nice demos on his website or his GitHub. And there's one here called Doomfire. So I'll show you the demo. And it runs, the flame simulation that's used in the Doom game. And it turns out it's really a very simple. If you go to this blog, I'll tell you how it works. But it's really surprisingly simple. So we go to this folder. We can look at his WebAssembly text format. Like I said, he wrote this in Vol WebAssembly. I don't have time to go through how this works in depth. It is pretty informative to have a look and understand how it works, but I want to call out a couple of things. The first one is that he's importing the rand function from JavaScript. So unsurprisingly, he didn't want to write a rand function in WebAssembly because it's relatively difficult. So he's imported the rand function from the JavaScript host. So that's how you get stuff from JavaScript and can call JavaScript functions. Similarly, this is something you'd have to do if you want to write to the DOM at the minute. Although I think there's a standard that's coming out to allow direct access from WebAssembly to the DOM. Then the next really interesting thing is the memory here. So in this memory call, we're allocating 5 pages of memory. And so memory in WebAssembly is allocated a page at a time. And each page is 64 kilobytes in size. And we've also made it available to the host under the mem variable with this export. Palette data, I'm not going to worry about that. This setup function basically starts the algorithm with a sort of row of fire at the bottom of the screen. And then the main function is here. It's this run function that gets called once per frame. I'm not going to go through it in depth. Well, I think one thing I forgot to say was you only have those 4 types, 32-bit integer, 64-bit integer, 32-bit float, and 64-bit float. So one thing that confused me at first was, well, what about signed and unsigned types? And for operations, and basically signed numbers are stored in 2's complement. So for some operations like add, it doesn't matter whether you've got a signed or unsigned type because the operation works the same. But for other things where it does matter, you'll find the operations, there's 2 versions of operation, one for unsigned and one for signed integers or whatever. And so that's what that underscore U is, I believe. Is there anything else I want to call out? Yeah, so store 8 is storing a byte in that heap. Yeah, and there's a lot in there. You can totally go and have a look at it. I'd recommend it. Maybe I should have made this a bit bigger. And then to run it, he's just got a simple HTML file. I think this is the raw WebAssembly. So he didn't have to worry about the content type problem I just told you about. So I think that's the raw WebAssembly from that he's compiled and just copied into this HTML file. And this is how we pass the rand function into the WebAssembly. So it's calling, when you call rand in the WebAssembly, it's actually calling math.random in JavaScript. Yeah, and that gets passed in with imports. And here we're setting up a JavaScript array that points to part of the WebAssembly memory, and give it the exact offsets. Then we set up the canvas that we're going to put the flames on, and from then on, basically, we're just running this exports.run method for each frame and updating the canvas data. So it's really impressively simple and really informative to kind of look at these demos. But that's not how you're going to be writing a WebAssembly in actuality. So I'm going to change back to the terminal again. Apologies for all this flip-flopping. I'm going to look at an example of, if I can remember the name of it. Yeah. So I've taken this example from there's like a Rust WebAssembly book that's really quite nice. And one of the first things it does is walk through this example. And you'll see, yeah, it's not that easy to get hello world example that's minimal. So in this example, it does have a lot, I think it's lib.rs, isn't it? Yeah. Yeah, we are relying on a lot of sort of helper functions and stuff. But this is basically a very simple Rust file that will create a WebAssembly program that will call a JavaScript alert to say, hello, CraftConf. There's a few things in here. One thing is WASM bindgen. This is very important. And WASM bindgen basically creates a lot of functions, helper functions, and code to go between the Rust WebAssembly and the JavaScript, and also from the JavaScript calling into the Rust WebAssembly. So it's dealing with all the types and exposing methods, etc. Excuse me. So here we're saying we want to call the JavaScript alert method. And here we have the function that we're going to export, which is a greet function. And when it's called, it's going to call the alert method with the string hello CraftConf. Okay, I'm not going to compile it this time. What I'm going to do is I've compiled it earlier. And what I have is a www directory here. And this is actually an NPM project that's going to run this example. So it is considerably more complex. And if we look at index.html, it starts off in a very simple HTML page that just calls this bootstrap.js method. And I guess that bootstrap.js method then sets up all the WASM bindgen stuff and various other things for calling WebAssembly back and forth. But in the end, it will call index.js or something called index.js, which imports our Rust WASM hello WebAssembly, or imports this function from it, and then we call greet. And so that's where the actual magic happens. Okay, so we call npm start. Hopefully this will work. Looks good. And I'm going to go back to the browser, hopefully for the last time. Yeah, if we go back to localhost 8080, this time we should get a pop-up. Yeah, so localhost 8080 says hello CraftConf. So again, a slightly uninspiring example, but hopefully it explains how a more realistic example of how you'd actually write code that compiles to WebAssembly and use WebAssembly in practice. Okay, so I'm going to go back to my slides. I don't think we crashed like the Ever Given. Okay, so the first thing you might be asking after seeing me code in Rust is, well, I don't know Rust, so can I use my own language? An answer is probably. If you go to this GitHub page, which is AppCypher Awesome WASM Langs, you'll see a whole bunch of languages that compile down to WebAssembly. And there's fairly good support for some of them, but they're not all equal. So Rust and AssemblyScript are really good at producing WebAssembly. And there's also stuff, LLVM compiler has good support. So if you're happy to use something like C, you've also got good support. But when you go outside of those, things tend to get a bit more complicated, especially when you have languages that have garbage collectors and runtimes, which is most languages, frankly. Because if you use Go, which obviously has a garbage collector, the problem is you have to have the implementation of the garbage collector in the compiled WebAssembly at the minute. And Rust is fortunate in this case because it has a very unique sort of memory model and doesn't have a garbage collector, so it works very nicely with WebAssembly. And you've got similar problems if you have like interpreted languages like Python, where you need to have support for that inside the WebAssembly. So do be aware that although there's lots of stuff that can compile WebAssembly, they're not all equal, if you like. Okay, on a slight tangent, there's a very, very important standard called WASI that people started working on not that long ago, so it's still in a fairly early stage. And basically, it describes how WebAssembly can talk to the host operating system. So in sort of Linux terms, make syscalls, if you like. And it's all to do with like what input output you can do to the host itself. So like creating files, writing to files, reading from files, and same with sockets and standard in, standard out, things like that. But one really nice thing is, security is very much front of like their minds when they're developing the WebAssembly, I think it's system interface it's called. And so everything's handled via capabilities. So you can set very strict restrictions on like what files or what directories WebAssembly can access and whether it can open sockets and which sockets and things like that. So there's a very strong security story there that complements the very sandbox nature of WebAssembly. Yeah, there's already implementations for multiple hosts, obviously Linux, but other things is like a polyfill for browsers and so on. Okay, so I want to move on to talk about why I think WebAssembly is going to be so important. And there's someone called Kevin Hoffman, who's written a book on WebAssembly and is currently working on a runtime for WebAssembly that involves the actor framework. And he's fond of saying WebAssembly is the future of distributed computing, which is quite a grand statement. But I think it's pretty accurate because I think WebAssembly is a very good choice for solving a lot of the problems that happen in distributed computing regarding sharing code between multiple machines, possibly in different places on different architectures, etc. And in some ways, you can think of it, or certainly if you have a certain age, you can think of it of fulfilling the promise of Java. So when Java first came out, and not first came out, but when Java was in its early stages, in the late 90s and early 2000s, we used to talk about write once, run anywhere, or write once, run everywhere a lot. And this idea that once you compiled your Java bytecode, it could run on any architecture anywhere, and it was going to end up being ubiquitous and everywhere. Now, it didn't I think Java did really, really well, but it arguably never fulfilled quite that promise it said it would. And there's a few reasons for that. And I think most of those reasons are addressed in WebAssembly. So one thing is the size of the JVM. And also in the early days of Java, people complained about it being slow. I certainly wouldn't call Java slow these days, but people still complain about the memory it uses and things like that. And WebAssembly creates relatively small WebAssembly files, and the WebAssembly runtime itself can be really pretty small as well. And that comes down to having a simpler specification. And on that point, one of the jokes about Java was it wasn't write once, run everywhere, anywhere. It was write once, debug everywhere. Because the problem was there's the different JVM implementations, and they all worked slightly differently and had different bugs and so on. And because of the similar specification for WebAssembly, I'm kind of hopeful that that won't be the case for WebAssembly. Also, the thought out system interface with WASI, I think, is a big key feature of WebAssembly. And although I don't think Java did a bad job, in this case, it didn't have the same sort of forward thinking from the start about this. Yeah, and the final point about being language agnostic. So certainly in the early days of Java, if you want to write Java bytecode, you have to write in Java. There were other options like Groovy, I think it was, and JRuby, but they were fairly niche and certainly not as mature as Java itself. And nowadays it's a different story with stuff like Clojure and Scala. But hopefully in WebAssembly, we'll be able to use languages like Rust and AssemblyScript, and hopefully a lot more languages like Go and so on to write our WebAssembly. Oh, on to another point. So at the start of the talk, I did mention that you can think of WebAssembly as solving a lot of the use cases of containers. And Solomon Hykes, who was the founder of Docker, actually wrote that if WASM and WASI existed in 2008, they wouldn't have created Docker, which is a big statement to make. And it's really quite interesting when you sort of dig into why. And it's basically because WebAssembly gives you, as I said, like a portable, secure way to build, distribute, and run code, which is pretty much what Docker gives you, at least if you squint a little bit. So definitely WebAssembly addresses a lot of the same use cases as Docker. Or containers, perhaps more accurately. And on that point, I'd like to sort of move on to talk about not use cases, but use cases. I do hope if we were in real life, I might have got a chortle there, but in the virtual world, I'll just pretend. Okay, so I guess the first use case, and the use case that perhaps drove people to build WebAssembly and the standards and so on, is running stuff in the browser. So primarily perhaps games. So games, very CPU intensive, didn't always work wonderfully in JavaScript. And so the Unity framework already, and for some time, has been able to compile into WebAssembly, so you can run pretty complex games in WebAssembly. And that in a similar way, there's talk of virtual reality headsets running WebAssembly, possibly writing stuff like image editors and sound editors, things that take a lot of CPU power, are more appropriate perhaps for WebAssembly than straight JavaScript. So it can bring a lot more stuff to the browser, hopefully. On a very similar point, there's this idea of porting desktop applications. So there's a use case here where Autodesk can make AutoCAD. And through the years, they've tried to port AutoCAD to the browser using various different methods. So there was like a Flash implementation at one point and so on. And recently they've been playing with WebAssembly, and you can go and look at presentations on this. Basically, AutoCAD is a C++ application, and they were able to compile the C++ to WebAssembly, which saved them from having to do a lot of rewriting Like if you do this in JavaScript, obviously you have to rewrite anything in JavaScript, but they were able to directly generate the WebAssembly from the C++, which saved them from having to rewrite things and fix the same problems all over again. So that's a really interesting use case. And if you can do it with AutoCAD, there's no reason that you can't do it with a lot of other like C++ stuff that typically runs on a desktop, things like audio workstations or video editing, perhaps, things like that. And I mentioned this before, but I think it really will be a big use case with functions as a service and running WebAssembly. Yeah, as I said, the two big ones at the minute, are Fastly's Computer Edge, I believe it's called, and Cloudflare Workers, which will both run WebAssembly for you. And WebAssembly is really pretty nice for this use case because it means Fastly and Cloudflare don't need to worry about how you create the WebAssembly. They just need to run it. So they don't need to worry too much about creating SDKs for all these various different languages. They just need to provide WebAssembly to them. And WebAssembly starts up really fast. So it's going to be faster than, for example, using Docker containers to run functions as a service. So it really seems quite a strong use case here. I already mentioned plugins or embedding WASM in other platforms, so Ethereum smart contracts. But another really interesting one is the Envoy proxy that's used in Istio and other places. So at the minute, if you want to add custom functionality to Envoy, you would have to edit the Envoy source code, write your custom code in, and then compile it again, which isn't great. Because we compile every time you want to make a change. So Envoy are looking at allowing people to bring their own WebAssembly plugins and making them available for, also making some plugins available publicly for download and so on, which is a really interesting use case. And even like Linkerd, which is a competitor really to Envoy and Istio, they're looking into whether or not they'd be able to support the same plugins. So yeah, some really interesting stuff there. Yeah, embedded in IoT also seems to be a really strong use case for WASM. Although, WASM might not be as fast as straight, compiling straight to the architecture. There's so many advantages to running like WebAssembly in terms of not having to recompile and being able to distribute it easily. That is really quite a strong story. So there's already stuff like WASMer that I showed you running on my terminal and WASM 3 that are designed to run in constrained environments, like with low levels of memory and low levels of CPU. So I suspect you will start seeing a lot of IoT stuff running WebAssembly in the near future, and embedded stuff. Another really interesting use case is Crustlet. So if you use Kubernetes, you can install Crustlet. And what it will allow is it'll set up a kubelet, which will allow you to run your WebAssembly directly on it. So basically, your WebAssembly modules become pods in Kubernetes effectively, which seems, I've not played too much with it, but it seems a really fun and powerful idea. Finally, this one's a bit more complicated, but those of you that know what unikernels are or play with unikernels, I think WebAssembly and WASI probably have a really strong story here, because WASI effectively defines what parts of the kernel that you require. So if I have a WebAssembly program and a WASI specification for it, I can compile something like a virtual machine or a VM image or even a binary that will run directly on a host. And so it has all the functionality it needs to run just the parts of the kernel it needs and the program. So I can end up with something that's perhaps just a few kilobytes in size, starts up in microseconds and runs on hypervisor or even on bare metal. So that's a really interesting story. I think it'll be interesting to see if that does take off. Okay, that's pretty much all I've got. I just want to talk a little bit about recap what I've been talking about. So we can think of WebAssembly as being a better version of containers effectively, because they're secure. A lot of thought has gone into security, and arguably they're easier to secure because there's so much less in it than there is in Docker containers, which really require the whole Linux kernel. The portable, arguably more portable than Docker containers, because you require a different Docker container for each architecture, whereas you only need one WebAssembly. Although you do require a WebAssembly runtime to run it on, and they're language agnostic, at least to some extent. You can also think of if it was fulfilling Java's promise, finally, this idea of write once, run anywhere. And so I can run the same code, on my laptop, in my Arduino, in my Raspberry Pi, in my set-top box, in my mobile phone, etc. But the really exciting things, we're still reasonably early days in WebAssembly, so I'm really interested to see where things go next. And I hope more and more people use it. Okay, so thank you very much for listening.
Thank you, Adrian. That was very exciting, and it's been very interesting watching like the evolution of WebAssembly over the years. We actually have a few questions. Well, one question so far, but I'm guessing there's going to be a few more. Peter is asking, we have seen some nice examples in your presentation. What do you think about WebAssembly's performance? Is it comparable to native code? Especially, are concurrency limits bound to web workers only?
That's a good question. I'm going to stop sharing if that's okay.
If you wouldn't mind just leaving it up so nothing gets confused. Or...
Oh, I didn't click it there. I might have clicked
it. Fine. It's fine.
Sorry.
Don't worry. You're good. Everything's fine.
I'm sorry. Sorry, breaking things as usual. That's a really good question. So what you'll find is there's different implementations of WebAssembly runtimes. So there's stuff that works like a just-in-time compilers, and there's stuff that, and there's also interpreters like WASM 3 and so on. I think the stuff I've been reading is stuff about 2 times, half the speed of running natively is some of the stuff I've read. But it'll depend on your exact implementation that you're using. But yeah, it's going to be pretty fast. And actually, one use case is like in Python. And one thing I didn't talk about is calling out to WebAssembly from different languages. So for example, you could have Python code, and when you want to do some more high performance, you can call out to a WebAssembly library, for example, that's going to run faster than your Python.
Yeah, that's pretty exciting. What do you think about the second half of this, about concurrency limits? Are concurrency limits bound to web workers only?
I'm not sure it's an honest question. I think there might be some confusion. I don't know enough about how it works in the browser to actually answer that.
Yeah.
Oh no, I see what you mean. Yeah. I don't know is the honest answer. That's a good question.
That's a rare kind of honest answer at the conference. Thank you for that. Zoltan is asking, not me, Zoltan. Are there any existing production apps using WebAssembly which are not just tech demos?
Yeah, that's another good question. I suspect there is. Everything that I've been playing with was largely a demo, to be honest. I think everything I've gone, like all the use cases I talked about, all the things I've seen are demo or in progress. I mean, there's definitely stuff that will happen. And Unity has been using, I think that's probably the closest I can give you is Unity has pretty strong WebAssembly support. So I'm sure you can find some games that use WebAssembly. Beyond that, I'm not too sure.
Yeah, fair enough. While waiting for maybe more questions to come, we still have a little more time. I'm wondering, like, if I'm, say, like your run-of-the-mill web application development company, we've got a web app, we've got maybe a mobile app, like at what point or would we ever consider today using WebAssembly?
Yeah, that's a good question. I'm not quite sure is the answer, but one interesting thing in a project that I work on, we created like a UI, like a GUI for our project. And we used this project called YEW, which is basically a Rust WebAssembly version of React. And it worked really well. I was really quite impressed with it. And the nice thing about that was we kept all our code in Rust, and we didn't have to have, TypeScript or JavaScript that I didn't understand in it. We could keep everything in Rust. Where was I going? Yeah, the only thing was, I think because WebAssembly, at the minute, you've got to call out to JavaScript to talk to the DOM or do DOM operations. So goes through JavaScript for every operation, which makes it a little bit slower. And for that reason, you're not going to see any. I think it'll be a while before you see people writing stuff like that in WebAssembly, but I think that will be a use case in the future. For the minute, all that stuff's staying in JavaScript. Does that answer the question?
I think it does. Yeah, I mean, it makes sense to me. Cool. Yeah. So let's just see if any other questions show up. In theory, we still have like 5-ish minutes left, and there is some latency by the time between us logging here and the video actually making it out to the stream. So I'm just gonna fill time a little bit, see if this jogs people's imaginations and the other stuff comes in. But if not, then yeah, I'm just gonna thank you very much for your time. This was very exciting. I always love hearing about WebAssembly, and we actually have a little special gift prepared for you. Maybe you can show it on the screen, and then we'll work on getting it to you in the physical world. See if we can. There we go.
No, I can't see it. Probably everybody at home can see it, except me.
Oh, that's kind of sad. Maybe you can scroll back on the stream on Hopin. I'm gonna spoil it for you. It's a mug. Like this is a cool mug. This is not that mug. Yours is much cooler. It has custom artwork. It's so cool.
I have talked at CraftConf before. So on the wall behind me, there's 2 pictures at the bottom. You probably can't see them, but those are from CraftConf.
Ah, nice. So you got more memorabilia coming up then. Amazing. Cool. Yeah. So once again, thank you very much for your time. Cool stuff. Hope you have a great day today. Thank you for being here.
No, thank you very much for having me. Goodbye.
Bye.